Been doing a little bit of exercise via the old rowing machine lately, just trying to, on the big continuum between Santa Claus and Brad Pitt, trying to edge a little bit towards the Pitt end. And one of the things which has been bothering me about it has been the numbers on the actual device itself. So there's a lot of information that you can see on the device, and I assume it's good information for some people. For me, it's quite a distraction, and I find myself chasing numbers rather than paying attention to proper form. And so I have taken recently to turning all the numbers off and actually setting my phone for the amount of time that I want to row. But then the problem is that as it gets closer to what I think the time is, I start to wonder about whether I actually did set it correctly or not. So I do need some sort of visual information, but perhaps not what's available. So this is what I have decided to come up with, call it the rowing clock. So what I'm going to do is have this enclosure, which at the top where I can't see, so this will hang from the wall, there's an on-off switch, and then there's a TM1637, which is useful for it's a 4-digit 7-segment display, so that will be where I will be setting the time. I'm going to put a little rotary encoder in here to set the time, so that'll be going one way, lessening the minutes, going the other way, increasing the minutes, and then actually pushing it to set it. There'll be some beeping noises here, which I'll explain in a minute, and then at the front is a 16 LED WS2812 RGB ring, and what that means is that I can control the color of all of these 16 RGB LEDs. So the plan is that when you switch the device on at the top here, then the TM1637 will flash 0000. You set the time to the minute. I'll have an error checking in there, so you can't set 0 and you can't set, let's say, I don't know, maybe 5 to 120 or 1 to 120 or something like that. I figure 2 hours rowing is probably about right. As soon as you push to go, you'll get maybe a 60-second or a 30-second countdown, and then all of these LEDs at the top. So this is just a spreadsheet, just helping me to figure out the logic behind programming it. But all of the LEDs will be green, and then every 10 seconds or so they'll flash. And then when you get down to the last 10 seconds, then it will flash every second. And then when it gets down to the last 5 seconds, it'll flash and beep. So that's the beeper there. As soon as it hits 0, the very last one, which I imagine will be this one up here, will go yellow. And then what you need to do is, what I need to do in the programming is to work out what is the time interval. So here I've just done a rough calculation. If it's 10 minutes, then that's 600 seconds. And then if we've got always 32 intervals, then that's going to be 18.75 seconds per interval. And I'll just round that off. I mean, I don't see any reason to worry about a second here or there. This is not extreme timing. It's just a visual clue for how much time I've got left to row. So the second interval, then it will drop down to red, that very last light. So that's this one here. And then it'll go to, that LED will go off. And so it's this one here. And then the next one will go yellow for the, the third interval. So, yeah, and I've got all the times down here as well. So that's the plan. So the first thing to do is to figure out what do I want to drive this. And I've been thinking about the Arduino Pro Mini. So I'm going to get one of those out, and I'm going to have a look at, can I make it work? Because programming is via an FTDI link. So we'll just see if we can get it to program up. Do some beeping, some flashing, get the LEDs working with it. We'll get the TM1637 working with it. 3D print up a case, and hopefully we'll have a rowing clock at the end of all of that. Here's the rowing clock prototype, and I'm actually going to plug it in and give myself a couple of minutes to describe what's going on, so there'll be a bit of pressure. So we've got 1 minute showing up at the moment. Now I have to hold this a little bit carefully because those pins aren't very long, but I should be able to wind up. There's 2 minutes. That should be enough to describe what's going on. So in the case of exercise, of course, you'd probably wind it up to something like 30 or 40 minutes or whatever you're doing, really. And then you just press this, and there we go. We're beeping and ready to run. Now, it does not an awful lot to start with because it's going to give you time to start the exercise, to get into position or whatever you need to be doing. So that's what that's doing. It's counting down at the moment. So here's what we've got. We've got the Arduino Pro Mini in the background there, and it's programmed using an FTDI programmer. So that's, I guess, one twist. There's no USB that you connect up. And oh, there's our 2 minutes starting now. There's a little passive buzzer and a 20 ohm resistor. And I think that's at 200 kilohertz, and that's using the tone library. But all the code is linked in the blog anyway. There's your rotary encoder, and I spent quite a bit of time trying to find a rotary encoder library that was going to work for me. And chief problem was because this is a very cheap rotary encoder, I needed to have a good debouncing routine. So I'm also probably going to hardware debounce it by putting in a couple of maybe 100 nanofarad capacitors on this as well. But in general, I've found that the library that I'm using now is pretty good. So this is the TM1637. So that is a 4-digit 7-segment display, and I'm using the library for that as well. So you just basically send it what you want in terms of a decimal number, and it will print it out. So it's all pretty straightforward. I'm relying pretty heavily for this whole project on other people's work, which is good to be part of the Arduino community when it comes to that sort of thing. And of course, the main part is the FastLED library, which is in charge of these 16 LEDs. And you can see that each light goes on in turn for amber and then for red before it cuts out. That gives you 16 times 2, 32 states. There's a little bit of maths inside there to work out what the interval is between each state, and basically then it just counts down. I've timed it for 40 minutes, and it's pretty accurate to within a few seconds, so that's fine for the purpose that I need it for. So it's about to reach now the 0 state, and then what it'll do is it will flash and beep to let you know that the timer is finished. Then it just goes into this amber ring, which will just count down, and this is your warm down cycle, which takes a minute or so, and then it'll just shut down and go to sleep. So that's the prototype working. The next thing for me to do is to take the 3D printed container and to take all the supports off it. I'm going to solder this all up on a PCB. I'm going to put a cradle for the Pro Mini so I can pull it out. The other alternative, I guess, is to have something connected up permanently to these pins so that I can always program it when it's like in situ. But I figured it'd be easier just to have a cradle and pull it out and program it that way. Although I'm pretty happy with what the program's doing at the moment, so I'm anticipating not needing to actually reprogram it at any stage. So we're just about to finish the warm down cycle, and then what it should do is it should completely go to sleep, and then reset is basically we'll be turning it on and off again. All right, so that's it. Let's get the 3D printed container all cleaned up. Let's get it all soldered up, and that is the rowing clock done. And here's my little 3D printed box. This was the most difficult part until I found the routine that does radial symmetry, so I might do a quick video on that. This looks incredibly ugly until you realize that most of this is support. So this bit will come off, leaving just a little hook on the end here to actually mount it when you're ready to use it. This will be where the on-off switch goes. This is for the rotary encoder, and then there's some little holes here and a mount on the other side for the buzzer. The only other thing I was thinking about doing, which isn't in the original design, is I might on this side just drill a little hole and put a little LED in here to indicate power. And power in this case, I usually get power from batteries, but in this case I think I'm going to use a wall wart, a little micro USB adapter, and yeah, I've just got a couple of capacitors there to smooth things out, and I will mount that at the back there, and that will be about it. So I'm going to remove all the supports now. I might go into the mode for time lapse, and also I'll have the old Dremel going, so that might be a bit noisy as well. So we'll see how that goes. So I'm just going to show you radial symmetry because it's actually pretty handy. So this is just a lid, a simplified lid, and I'm going to select it and then go to the sketcher, and then I'm just going to create one hole at a particular point. So let's do that. Let's make it round this time. I'm just going to wireframe, and the ones that I used were square obviously, but it doesn't really matter, does it, just for the sake of it. So we're going to make a little round hole here. Let's say with a diameter of 1.5. Okay, so then we'll just make that as a hole in that lid, and then what we'll do is we want to do radial symmetry on that one. So if we select that hole and there we go. And up here, this is to create a polar pattern feature. And then you just say, okay, so I want, well in my case I wanted 16 of them. So we'll go for, let's say 8. And then just click on OK. And back to, yeah, so that's what it looks like. I mean, that's pretty simple really. So that's how I got those holes for the LEDs. And here is the lid, which is just a couple of layers and a little cutout there for the USB slot. So yeah, that'll fit over the top nicely, and just keep the dust out. So this is just showing the back with a little cutout there for the micro USB adapter, and also the little LED there to indicate that it's on. So let's fire it up and see how it goes. Okay, so starting it up, you just get the minimum amount of time there, which is 1 minute, and you can dial that up as high as, I think I went for 180 in the end, 3 hours, which is a bit too much. And then once you press it, it should start its cycle. A little bit of razzle dazzle at the start, and then you just have the countdown to the actual exercise itself, and then from then on it's pretty much as we saw it on the breadboard. So that's the circuit working. Great project, lots of elements to it. I really enjoyed doing it and end up with a useful product, so can't get much better than that. See you next time.